Welcome to Applications of Derivatives, Lesson 1, Introductory Interpretation of Derivatives. We will use y and y prime to find out whether a function is increasing or decreasing, concave up or concave down at a point and on an interval. So let's go ahead and look at y prime and y double prime just to see what we're talking about, or f prime. F prime describes the slope, right? The derivative describes the slope. So if the slope is positive, if the derivative f prime is positive, what's happening to f? F is increasing. How about if the derivative, the slope, is negative? Then f would be decreasing because it's going downhill. Okay, f double prime equals the rate of the slope change. F double prime, if it's positive, it tells us that f is concave up. And if f double prime is negative, then that tells us that the original function f is concave down. So let's look at a couple of functions and find out whether it's increasing or decreasing, concave up or concave down. Alright, so y prime equals 2. Y double prime equals 0. So y prime of 3 replace each instance of x with a 3, 2, because there are no x's to replace, and y double prime of 3 equals 0. That tells us that y is increasing at x equals 3, and y has no concavity at x equals 3. And that makes sense that it doesn't have any concavity because it's a line. Moving right along. Okay, y prime equals 2x plus 4. Y double prime equals 2. So y prime of 3 equals 2 times 3 plus 4. Y prime of 3 equals 10. Y double prime of 3 equals 2. So y is, hey, I said it right this time, increasing and concave up at x equals 3. And that makes a lot of sense because we know on a parabola that has a positive coefficient for ax squared, that's going to be concave up everywhere, and if the coefficient of x squared was a negative, then it would be concave down everywhere, and y is increasing. Alright, let's try one more. Cubic function this time. Y prime equals 6x squared minus 12x minus 18. Y double prime equals 12x minus 12. So y prime of 2 equals 24 minus 24 minus 18 equals negative 18. And y double prime of 2 would equal 24 minus 12. No, not 1/2, 12. That would equal 12. So y is decreasing, and since the second derivative is positive, concave up at x equals 2. Okay, that's how you find whether a graph is increasing or decreasing, concave up or concave down at a given point. Now let's get to the tough stuff and talk about on an interval. Describe the intervals of the function where that function is increasing or decreasing, concave up and concave down. Alright, in order to do this, we're going to have to find some critical numbers. So first, let's go ahead and find the first derivative and set it equal to 0. And I will let you go ahead and do that. Hopefully you got the same thing I did. Y prime is equals 6x squared minus 12x minus 18. Set that derivative equal to 0. And now, go ahead and solve for x. Factor out a 6. X squared minus 2x minus 3. That can be factored into x minus 3. X plus 1 plus 1. So x equals 3 or x equals negative 1. Those are possible points where it could switch from increasing to decreasing or concave up to concave down. The other critical point is where the second derivative is equal to 0. Y double prime equals 12x minus 12. 0 equals 12x minus 12. 12 equals 12x. X equals 1. So our three critical values are 3, negative 1, and 1. Okay, what we're going to do next is we are going to set those values on a nice little number line. First we'll do y prime, negative 1, 1, and 3. Pick some values to fill in for y prime. And we'll go between negative infinity and negative 1. Okay, these critical values are the only places where there could possibly be a sign change, increasing, decreasing, or concave up to concave down. So let's see here, negative 10, pick out something nice. Negative 10 squared is 100 times 6, 600, plus 120 minus, oh, that's definitely going to be positive. Pick something smart here, 0, oh yeah. 0 minus 18, negative. I think 2 would be the perfect thing to go there. 2 squared is 4. 24 minus 18. And 3, pick something smart again, 10. 600 minus 120 minus positive. And now, y double prime, those same numbers again. Okay, let's see what happens to y prime now. Put in a negative 10 there. Negative 120 minus what? Oh, that's negative. Put in 0. It's negative. Put in 2. 24 minus 12. That's positive 12. And then put in 10. 120 minus 12. That's definitely positive. So, here's our conclusion then. Y is increasing and concave down on negative infinity to negative 1. Going to be a little repetitive here. Y is, now let's look at this next interval right here. The derivative is negative and the second derivative is negative. So it's decreasing and concave down on negative 1 to 1. Okay, third interval, y is still decreasing. First derivative is negative. Second derivative now is positive. So now it's concave up on 1 to 3. And then on the last interval, y is, it's positive and positive, increasing and concave up on 3 to infinity. And that's how you determine the concavity and whether the function is increasing or decreasing on an interval. Let's try one with a quotient rule and see if it's just as complicated or crazy. Alright, first I'm going to let you find the derivative of that using the quotient rule. I'm going to pause it and come back. Alright, I got y prime equaling 32 over 4 minus 4x, quantity squared. Okay, so let's go ahead and I dare you find y double prime. I'm going to pause that while you try to figure out what y double prime is again. Oh yes, the insanity again. Alright, that's what I got for y double prime, 256 over 4 minus 4x, the quantity cubed. It's cool how things kind of canceled away with it right there. Alright, now as I try to set either of these functions equal to 0, I'm not going to get any x's. Go ahead and watch. 0 equals 32 over 4 minus 4x quantity squared. Multiply both sides by that or cross multiply and you're going to get 0 equals 32. That is a disconjunction. However, critical values can also be found where the function is undefined. So where is that function undefined? That function is undefined where, in this case, the denominator equals 0. So 4 minus 4x quantity squared equals 0. Take square root of both sides. So add 4x to both sides. Divide both sides by 4, x equals 1. That will be our only critical value for y prime as well as y double prime. Y prime as well as, stop doing that to me, y double prime. So go ahead and pick some values and see whether it's increasing or decreasing, and concave up, concave down, and then come back. Alright, so when I picked my values for y prime 0 and 2, I found out that y prime is going to be increasing on both those intervals. And then when I picked those same values for y double prime, I found out it was concave up and concave down. So go ahead and write your conclusion for y, where it's increasing and decreasing, concave up, concave down, and compare your answer one more time. And here's my conclusion. Y is increasing and concave up on negative infinity to 1, and y is increasing and concave down on 1 to infinity. This does conclude Applications of Derivatives Lesson 1.